Welcome back. We're going to look at recursive rules for geometric sequences, and it's going to be very similar to what we did the other day with arithmetic sequences. So to review what this means, f of n equals f of n minus 1 times r. If you notice, everything looks the same except there's a times r instead of a plus d. So what this means is this is the nth term equals the previous term times, instead of the common difference, we have common ratio. And then when f of 1 equals some number, because we have to know where we start, this is given the first term. So if we take a look at example 1 and we write our recursive rule, I see right away that 1 is my first term. I also see that when we multiply to get each of these values, I can multiply times 6, times 6, times 6, and times 6. So I know my common ratio is 6. If I write what I had before to remind myself, the nth term is the previous term times the common ratio given the first term, I can use this recursive rule to write one specific to this sequence. And this is a geometric sequence because it's multiplication. So I can write f of n equals f of n minus 1, the previous term, times 6. I take every term and multiply it by 6 when our first term is 1. Looking at another example, I have 256, 64, 16, and 4. Right away, I can see that 256 is my first term. I can also see I divide by 4 every time, and we're always going to use multiplication for geometric sequences because they're related to exponential functions. We're going to, instead of divide by 4, multiply by 1/4. So instead of dividing by 4, we are multiplying by 1/4. So our common ratio is 1/4. To write our recursive rule, we say I can get any term, f of n, by taking the previous term, f of n minus 1, and multiplying it by 1/4. When my first term, I need to know where to start, is 256. So I also know that with example 3, I have a table, and I know that this is saying the first term is 27, the second term is 29. That's what those ends mean. And so right away I can tell that my first term is 27. And then to get from one to the next, I see that I'm dividing by 3, which is the same as multiplying by 1/3. So I know that my common ratio is 1/3. So to write my recursive rule, I have f of n equals the previous term times 1/3 when my first term is 27. That's where I start. And then from there, I multiply everything by 1/3. Looking at this example, I can easily tell that my first term is 6. And to go from 6 to 60 to 600 to 6,000, I multiply by 10. It's a geometric sequence again because we're multiplying or dividing. And so that means my common ratio is 10. To write a recursive rule, I can get any term by taking the previous term and multiplying it by 10 when my first term is 6. And that's the notation for how we write that, what I just said. Oops, and I didn't mean 6. Oh, yes, the first term is 6. So now if we take a look down here, I know that this is a geometric sequence because I have this times right here. So looking at this, I can easily tell that my first term is -1. So I know that that's going to go right here in the first slot. I also know that the 3 multiplied by 3 is a common ratio. So I'm going to be multiplying by 3, multiplying by 3, multiplying by 3 every single time. So -1 times 3, we have -3, times 3 is -9, times 3 is -27, and -81. So I want to find the 7th term of the sequence, which means I have to have the 6th term. So if I plug in 7 for n, because that's the nth term, I get f of 7 minus 1 times 3. 7 minus 1 is 6, so I need the 6 terms times 3. So I know the 7th term equals the 6th term times 3. So I already have 5 terms, so if I add 2 more over here, I get -243 if you multiply by 3, and then -729. So I do know that f of 7 equals -729.